Section 5.1 Adding and subtracting polynomials. Objective number 1. We want to define the monomial and determine the coefficient and degree of a monomial. Definition of a monomial in one variable is the product of a constant and a variable raised to a non-negative integer power. A monomial in one variable is of the form ax to the k. So let's explain the definition in this case. So we understand this is the product means multiply. So a constant is like a number. So let's call a is a number like 2, 3, 1/2, -5, -10, and so on. Variable means letter. So this is the product of number and letter. So that's what just it means. And for the letter, raised to a non-negative integer power. So non-negative integer means 0, 1, 2, 3, 4, 5. So x to the power of k, and for k will be 0, 1, 2, 3, 4, 5, and so on. So it's called the non-negative integer power. So that's why you have in the form ax to the k. And k is greater than or equal to 0. So k is 0, 1, 2, 3, 4, 5. Okay. And they said that if we just have a constant a, the coefficient of the monomial a not equal to 0, then k is the degree of the monomial. Okay, so we were talking about the degree for that later, but let's look in the bottom for number 1. Identify the coefficient and the degree of the monomial. So the coefficient will be 5. We just pick the number in the front. The coefficient is the constant a. That's what it says. A is the coefficient of the monomial. So the number is in the front of the letter x is coefficient. So 2/3, and then 8 itself, and then 1, because this is like 1, -1, and the coefficient is 0. Now we do the degree. So by definition, the degree is the k. So we have k is 3, which is right here, right? So k is the power. So k is 3. So the degree is 3. The degree is 6. For part D, the degree is 2. This is like 1. Okay, so when we have a number, so let's look at the 0 above. So we have the 0. So we have 0 like times x, 0 times x squared, 0 times x to the third power, and all of them is the same as 0. So that means the x to the power can be anything. So when we have that case, then 0 has no degree. So in this case, we have no degree. Okay, and then we have x times 8 times x to the 0 is the same as x times 8 times 1, and that's give us like a. Okay, so the power in this case, the degree in this case will be 0 for part C. Example number 2, expression that are not monomial. So they're just telling you that the example A and B are not the monomial, so let's understand why. So we look at this, so we can see that the degree is not the degree, but the power is 1/3. So 1/3 is not integer. The integer is all 0, 1, 2, 3, 4, 5. So this is fraction. So this is not integer. So by definition, the power have to be the integer. And then -2 is not non-negative. It have to be from 0, 1, 2, 3. So -2 is not from this list. So that's why example 2, A and B, they are both not monomials. Number 3, example number 3. This is the example of more than one variable. This is the monomial, but more than one variable. So -4 is a constant. It's a coefficient. It's a number. So it is a coefficient. This is a constant, right? But we call the coefficient by definition. And 10 is also the coefficient also. Okay, so we have x to the third and y to the second. So when you have more than one variable, the degree, you will add them up. So 3 plus 2 is 5. For problem B, the exponent of 8 is 1, so the degree will be 1 plus 5. So that will be 6.